It could be here. Theta could be here or here. It can never be your 90-degree angle though. Okay, so opposite of this angle, the adjacent is right next to it, and of course the hypotenuse is right across from the 90-degree. So to find an angle, whenever you're trying to find an angle measure, you have to use the inverse, and make sure your calculator is in degree mode, because as you know, there's two different measurements for angles. It could be degrees or radians. So calculators have three modes: degree, radian, and then there's one called graduated radian, which I don't even understand that one, to be honest, but we want everything in degrees. So we're no longer using radians. So pi over 6, that's gone. We're finished with that, okay? So make sure your calculator is in degree mode, and you should see like a DEG at the top somewhere. And after we do some examples, if you don't see that, I can help you figure out how to put your calculator in the right mode. I think most calculators default to degree mode though, so it's probably in degree mode. Okay, so go ahead, let's find let's go ahead and practice. Put in the sign. I want you to type in your calculator just to make sure you have it in the right mode. Type in inverse sine, because you have to do the inverse sine of 5 over 12. Type that in your calculator right here. Type this in, inverse sine of 5 over 12. And if you don't get 24.624, then your calculator is in the wrong mode. Raise your hand and I'll help you put it in the right mode, or bring it up here. But if you got that, then you are in the right mode. So we in the right mode? All right, so we ready. Okay, so example 1. So we have triangle ABC. A is 4 and C is 5. So I want you to put, when it's a lowercase, that's a side length. So lowercase letters, lowercase, that's a side. Okay, capital, that means we're looking for an angle. So when it says triangle ABC, where little a is 4 and little c is 5. So let's go ahead and label that on our calculator. Notice how little c is opposite of big C. So this big C represents angle C. Little c is directly across. So let's put our 5 here. Oops. So 5 is my little c. And then what else did they tell us? They told us that little a is 4. So the first thing they want us to do, this is our first step. Go ahead and cross out the color, because we're not coloring anything. Find little b. So go ahead and find little b using Pythagorean theorem. You probably recognize what little b is without doing Pythagorean theorem. But if not, c squared equals a squared plus b squared. So 5 squared equals 4 squared plus b squared. Go ahead and find. That's for part A. So 3, 4, 5 is a real common right triangle. So you probably know that that's what it is. 25 equals 16 plus b squared. 9 equals b squared. So little b is 3. So that's the answer to example 1. So example 1, where it says find b equals 3. Okay, so now what we're going to do is find each of our ratios. So if I'm trying to find the sine, what two sides of my triangle? I'm trying to find the sine of A. See how that says capital A? So that means that our theta belongs here. So that's theta. They want us, this is my angle. So let's go ahead and label our three sides. So what would the 5 be? Is that the opposite, adjacent, or hypotenuse? So let's write that on our triangle. And then what would the 4 be? So if this is theta, it's opposite. And then we just figured out that little b was 3. So let's put that on our triangle. And that would be the adjacent. So when I'm writing the sine of angle A is going to equal 4 over 5. So that's the sine of angle A. What would the cosine of angle A be? 3 over 5. And the tangent of angle A would be what? 4 over 3. So we can use any of the three ratios to find angle A. So you have 3 choices to do part C. For part C, in your calculators, you could type in the inverse sine. All 3 are going to give you the same answer. So you could type in the inverse sine of 4/5. Or if you use cosine, you would do inverse cosine of 3/5. Or you could do tangent, inverse tangent. Inverse tangent of 4/3. So pick one, type it in your calculator to find the measure of angle A. If you type in all 3, go ahead and type in all 3 so you can verify and you can see that all 3 are the same. So that's really important that you know that. So when you're doing your test, which is way after spring break, our next test, I think I have Canvas up to date with our schedule. So we're starting chapter 8 before spring break, then we'll finish it after, and then our test is sometime in April. I don't know when. But they should all 3 give you the same answer, which is approximately 53.13. And the test will specify where to round to when we actually get to that. Guess we don't need that 0. All right, any questions about how we found that missing side or how we found the angle? So if you're looking for an angle, a capital letter, we have to do an inverse. So angles are inverses. Because angles are inside, think inside inverse. All right. So let's go ahead and look at example 2. So example 2, let me go ahead and put our markings there. You should have a theta right here, a √3, and a 2. And they want us to find theta. So what ratio, let's see what happened. Oh, cool. What 2 sides did they give us? What does that 2 represent? Is that opposite? Is the 2 opposite, adjacent, or the hypotenuse of this angle? So opposite. What about the square root of 3? That's the adjacent. So what trig ratio am I going to use? Sine, cosine, or tangent? What ratio uses opposite and adjacent? cotangent or tangent, but now we're using just the main three. Unless you have a real fancy calculator that has cosecant, secant, and cotangent, we're going to just stick with the main three, sine, cosine, tangent. So we're going to use tangent. So tangent of theta equals opposite over adjacent, which means that theta is going to be the inverse tangent of 2 over root 3. So go ahead and type that in your calculators. Type in the inverse tangent of 2 over root 3. And I'm just going to go to the thousands place. You should get approximately 49.107 degrees. Everything is in degrees. If you're not getting that, bring up your calculator so I can help you with it. Pretty straightforward. Okay, let's go ahead and look at example 3. So the first thing we want to do is draw out our triangle. In most cases, you won't have a diagram, so we have to draw out what they are telling us. So let's draw our triangle. So they're telling us that C is 90. So that means that I'm going to put my capital C here. And then you can determine where you're going to put your A and B. So I'm just going to put my A, well actually, put my A here and my B here. But C has to be 90. Okay, so what else did they tell us? They told us that little a is 5. So where am I going to put that 5? Is that this side? Is that at the bottom? Or is that here? Where is little a going to fall? At the bottom, because little a is always opposite of big A. So put the 5 down here. And then they said capital A is 25. So let's put our 25. So we have our diagram. And they want us to find angle B. So who remembers from geometry triangle sum? What do the angles inside of a triangle always add up to? 180. Yep. So y'all got something from geometry. So to find the measure of angle B, so capital B is going to equal 180 minus the two angles that we already know, because we know this is 90 degrees and we know this is 25. So 180 minus 90 minus 25. Go ahead and type that in your calculators to get the measure of angle B. So did you get 65 degrees? Okay, so 65 degrees. Now they want us to find, I'm right here on part, so that was the answer to part A. So part A is 65 degrees. So let me go ahead and write it over here next to that. Part B, let's find the measurement of side B. So for side B, I only know one side, so I can't do the Pythagorean theorem. If I want to do the Pythagorean theorem, I have to know at least two sides, but I only know one. The only one I know is little a. So we have to use trig to find the missing side. So we're going to go with, we could do sine, cosine, or tangent. Well, actually, no, we can't. We can't. I'm going to take that back. So if I'm trying to find little b, so this is little b. Let me go ahead and put that on my, this is little b. I'm going to use what was given. So using this as my reference angle, I want to use the 25. What would that b equal? Is this opposite, adjacent, or the hypotenuse? This little b, in reference to this angle here. It's adjacent. So let's write that on our triangle. And then I'm trying to find, oh, and I know 5. And what is 5? That's opposite. Okay, so what ratio am I going to use? Sine, cosine, or tangent? If I know opposite and adjacent, what ratio would I use? Tangent. Okay, so let's go ahead and set it up. So I have the tangent of 25 degrees. This is part B. The tangent of 25 degrees equals opposite, which is 5, over the adjacent, which is little b. Okay, so we're going to treat this like a proportion. Let's go ahead and cross multiply. So if I multiply this direction, I would have b times the tangent of 25 equals 5. So b is going to equal 5 divided by the tangent of 25. So go ahead and type that in your calculator. Take 5 divided by the tangent of 25, and that's going to tell you the length of side B. And we'll just do everything to the thousandths place. So we're just consistent, because I'm pretty sure that's what your homework says to do. So we'll stick with that. So if I type in 5, and I'm not trying to find an angle, so I don't need to use the inverse. So it's just 5 divided by tangent of 25. So if you type in your calculator 5 divided by tangent of 25, you should get 10.722. Who got 10.723 actually? Okay. So 10.723, that's my answer to part B. Okay, let's go ahead and find little c. So to find little c, I'm going to have to take this away. So now let's find little c, which is right here. And that's my hypotenuse. So let me be clear. There's a couple different ways you can find little c. You could do the Pythagorean theorem, because technically we know 2 sides now. But I always like to use the given information, because if I messed up part B, now I'm about to mess up part C. So I like to stick with the given information and not go off to do it unless I had to do the Pythagorean theorem. But we can use another trig ratio to find little c. So that's what I'm going to stick with. Okay, so for part C, C is the hypotenuse. So sticking with this angle here, I know opposite, and I'm trying to find the hypotenuse. So if I know the opposite, and because opposite was given to me, and I'm trying to find the hypotenuse, now what trig ratio am I going to use to find little c? Which one uses O and H? Not cosine, sine. Yep, we got to use sine. So we have the sine of 25 degrees equals opposite 5 over little c. Go ahead and solve that for little c. So to find little c, you're going to take 5 divided by the sine of 25. And you should get approximately 11.831. And that's part A, B, and C. Okay, let's just do one more example. Let's go to example 4. And then we'll end there for today. Take a minute, draw your triangle. Now we're using the letters B, C, D. And I like to label everything that they told us. So they told us that big B has to equal 90. And then we know that capital C is 43. So I'm going to put that in my triangle. And then they said little b is 14. So that will go there. We have to find 3 things. So take a minute. First, find the easiest thing to find would be this angle. So go ahead and use your triangle sum to find angle D. So what did you get for angle D? Who got 47 degrees? Okay, good. So that's the angle of angle D, because you take 180 minus 90 minus 43. So I know that this is 47 degrees. So that's the answer to part A. But then I only like to use the information that they gave me. So I'm not going to use that 47 because I don't have to. But to find little d, which would be this side, the hardest thing is figuring out what trig ratio you're going to use. So what trig ratio, this is theta, am I going to use to find angle D? Is that a sine, cosine, or a tangent? So this is the side that I know. This is the side I'm trying to find. So what would the 14 be? That's the easiest one. What would that be? Hypotenuse, because that's opposite of the right. So it's always across from the 90 degree. Directly across is your hypotenuse. And the D is adjacent to 43 because it's right next to it. So that's cosine. So cosine, so for part B, cosine of 43 degrees equals adjacent over hypotenuse. So I always make it a proportion. I cross multiply it. So when I cross multiply, I get D, 1 times D, or D, equals 14 times the cosine of 43. So go ahead and type that in your calculator. Type 14 times the cosine of 43, and that will be your answer. Everything out to the thousands place. All right, see if you can find C by yourself. So now I need to find C, which is at the bottom. So you're using these two sides. So figure out what trig ratio and go ahead and find little c. What trig ratio are you going to use to find little c? Let me take off the adjacent because we're not using that anymore. We're done with that part. Okay. So what is c? It's opposite. So, and I know the hypotenuse, so what ratio am I going to use? So we're going to use the sine of 43 equals opposite over hypotenuse. So C equals 14 times the sine of 43. Go ahead and type that in your calculators. And you should get 9.548. Okay, so Gabby, can you go to Canvas and see when our next homework is due? The next home.
It says it's due Thursday, but March 25th is Friday.
It is due Thursday.
Yes.
So I need to change the date. So it's due this Thursday. It's over right triangle trig, and it's from the textbook, right? Mm-hmm. Yes, it's from the book. So you have homework due this Thursday. This is a review, though. You know, I think it's pretty good. I don't know. So there is a book up there if you want to take pictures of the questions. There's a book in the front.